Good afternoon to one and all. Today I am going to discuss about normal forms. This is Pushpa Rani, Associate Professor, Department of CSE, MLR Institute of Technology. In this video, we are going to discuss about what is normal form, what are the different types of normal forms, and also discuss one type of normal form called disjunctive normal form. So first of all, what is the definition of normal form? Normal forms is also called as standard forms. Sometimes it is also called as canonical forms, or it is also called as accepted forms. What is the use of normal forms? The normal forms can reduce the number of prepositions in the given statement. The main advantage of normal forms is it reduces the number of prepositions in the given statement. For that reason, we are going to use the normal forms. Basically, there are two types of normal forms in the case of discrete mathematics. First one is called as a disjunctive normal form. Second one is called as a consecutive normal form. In the case of disjunctive normal form, it is written, main thing is concentration on disjunction symbol, that is a or. In the case of consecutive normal form, we are concentrating on the conjunction, that is a and. So, in the case of disjunctive normal form, it consisting of a conjunction of literals, whereas the consecutive normal form consisting of a disjunction of literals. In the next slide, we are going to discuss about what is meant by literal, okay, what is meant by disjunction, and what is the corresponding format of disjunctive normal form and consecutive normal form. The another name for normal forms is standard forms. It is also called as canonical form. The main advantage of normal forms is to reduce the number of prepositions in the given statement. Let us look at about what is the format of normal form. If it is a disjunctive normal form, it consisting of a literals, conjunction of literals. So, this is called as a literal. Conjunctions means in between each and every statement there is a conjunction. Conjunction of literals. This is one literal. There are three literals are there. Suppose there are three literals are there. The three literals are connected by using the symbol called disjunction. So, this is called as a conjunction of literals. So, P and Q. P and negation Q. These two are called as literals. Then, these two literals are connected by using the symbol called OR. This is called as a product. This is called as a sum. So, then disjunctive normal form is also called as sum of products. Sum of products. Sum is called as a disjunction and product is called as a conjunction. So, another name for disjunctive normal form is disjunction of conjunction or conjunction of literals. Every product consisting of either variable and negation of the variable. Okay, any literal is a combination of variable and connective and the negation of the variable. So, what is the objective? We need to convert the given prepositions either in disjunctive normal form or it is a consecutive normal form. What about consecutive normal form? Consecutive normal form is the opposite of disjunctive normal form, whereas disjunctive normal form consisting of sum of products, whereas consecutive normal form consisting of product of sum. Product of sum. Product of sum. These are called as sum of literals. Sum of literals. These sum of literals are connected by using the symbol called product. This is one literal. This is one literals. These two literals are connected by using the symbol called product. This is called as a consecutive normal form. The another name for consecutive normal form is product of sum. Product is called as a conjunction, whereas sum is called as a disjunction. So, another name for consecutive normal form is conjunction of disjunction or conjunction of disjunction of literals are present in the sum. So, the literals may be either variable or negation of the variable. These are connected by using the symbol called either sum or it is a product. In this lecture, we are going to discuss about the disjunctive normal form, how to convert disjunctive normal form, for the given problem statement or given statement, then what is the required format of descent to normal form? So before that, we need to follow some rules and regulations. What is the definition of descent to normal form? A formula which consisting of sum of elementary product. So sum should be present in between the products. There is a product. In between the products, there is a symbol called sum. That's why it is called as sum of elementary products is called as a descent to normal form. Any formula is in the form of sum of elementary product, then it is called as a descent to normal form. What is the procedure we have to follow to get the required format of descent to normal form? Suppose the formula consisting of the conditional statement or it is a biconditional statement. First of all, you have to replace that conditional statement and biconditional statement with and, or, and negation symbol. You know the rules of implications, that is a P and Q. We know the formula of P and Q, that is negation P or Q. That is the formula. So P biconditional Q, you know the formula of P conditional Q and Q conditional P. So we have to replace those symbols. How to replace those symbols? By applying the corresponding formulas. We need to replace the implications and by implications with the corresponding connectives like and, or, and negation. That is the rule 1. Second rule is apply the negation to the formula or for the variables. We need to apply the, first we have to give the importance for the negation of the formula or the variables, we need to give the importance. Third rule is we need to apply the De Morgan's law. So for the any variable consisting of a negation, we need to apply the De Morgan's law to remove the negation for the given formula. Then repeat the same process until we get the required format. To get the required format, we need to apply the distributive law to get the required format of descent to normal form. First thing is we need to replace the conditional statements and biconditional statement with the help of the corresponding formulas called negation, or it is a conjunction, or it is a disjunction, by applying the equivalent formulas. Second one is we need to replace the negation, any variable consisting of a negation, or for the variables we need to give the importance. Third one is we need to apply the De Morgan's law to the variables. Third one is we need to apply the distributive law. Repeatedly we need to apply the distributive law to get the required format of descent to normal form. Now let us discuss some examples how to convert the given preposition into descent to normal form. Consider the first example. So obtain the descent to normal form for P and P tends to Q. So here we need to observe the first we are going to give the priority for P implies Q. P implies Q. So we need to remove the implication by applying the corresponding formula for implication. What is the required format? We need to get the required format is sum of elementary product. The sum should be present in between products. This is the required formula. This is called as a literal. What the literal consisting of? Literal consisting of a variable and the negation of the variable. So we need to get this required format. To get the required format, the rule 1 is remove the implication by applying the corresponding formula. Let us discuss P and P tends to Q. What is the formula for P implies Q? P implies Q is equivalent to negation P or Q. Apply the negation P or Q. Then again we need to apply the distributive law. Okay. So apply the distributive law. We need to apply the distributive law to get the required format of DNF. Then P will be distributed to the negation P as well as P is distributed to Q. Then P and negation P or P is distributed to Q, P and Q. So then we are going to get the two literals. The two literals are called as a elementary product. Elementary product. The two elementary products are connected by using the and. That's why it is called as sum of elementary product. This is the required format of descent to normal form. Let us look at about the second example. So what is the second example? Obtain the descent to normal form. For the given statement, negation P or negation Q implies negation P and negation P and R. This is the given statement. So what are the implications that are present? There is a one implication. First, we need to remove the implications for the given statement. What is the formula for implication? P implies Q is equivalent to negation P or Q. Okay. So this is considered as a P. This statement is considered as a Q. Okay. Negation P. Okay. So that is a negation P. We need to apply the negation. Negation P or negation Q. So we need to apply the negation for the preposition. There is a negation P. Okay, this is the statement or Q. What is there in the place of Q? Q write as it is. There is a negation will be present. So apply the negation for the inside of the preposition. This is the negation P or Q. This is the negation Q. That is the statement. Then we need to apply the De Morgan's law. According to De Morgan's law, we need to take the negation out of the preposition. Negation will be taken out of the preposition. What you are going to get? So that is the negation will be taken out. That means the negation becomes a negation. P will be there. Negation of P becomes a negation will be P. That is a and becomes R. Then negation Q becomes Q. Okay. Or what is the next preposition? Negation P or Q. Apply the first thing and the second thing. Please observe the first one, second one. This is the product. These two products are called as letters. These two letters can be combined by using the symbol called sum. So this is called as a sum of elementary product. Next. Coming to the third example, for obtain the descent to normal form for the statement P implies Q and then negation Q or negation P. That is the given statement. So we need to apply the conditional law because there is a conditional statement is present. First, we need to give the importance for the conditional statement. So what is the conditional statement? P tends to Q and Q then or negation P. This is the given statement. So what we are going to do is consider the conditional statement P implies Q. What is the formula for P implies Q? Negation P or Q is the formula. So in this statement, this is considered as a P. For the first preposition is considered as a P. The entire preposition is considered as a Q. The entire preposition is considered as a Q. What is there in the place of P? P only, that is written as negation P or what is there in the place of Q? Write the entire statement. There are two parentheses. So be careful about the parentheses. Next, two parentheses. P tends to Q and negation of negation Q or negation P. Okay. Still there is a P tends to Q is present. Okay. Still P tends to Q is present. Again we need to remove the P tends to Q for the second preposition. So write the negation P or okay, or should be written as it is. Next, for P tends to Q, apply the formula negation P or Q and apply the negation for the inside of the preposition. Here there is a two negations are there. According to double negation law, negation Q becomes Q. Again negation R becomes and. Then negation P becomes P. That is the required format. So again we need to apply the De Morgan's law. According to the De Morgan's law, apply the negation for the inside of the preposition. We are going to get this required format. Next, this negation P will be distributed to multiple statement. Negation P can be distributed to multiple statement. Negation P or okay, then this negation P can be distributed to multiple statement. Negation P is distributed to Q and P, then it becomes a negation P and Q and P. Again Q is distributed to next statement, or is there, in between there is a or is there, Q and negation Q and Q according to the distributive law. So still negation P, write as it is negation P. So Q and P will be written as it is Q and P or Q and P. This is the required statement. Next, again Q is distributed to multiple statement according to the distributive law. Negation P, write as it is. This negation P and Q and P write as it is. Again Q will be distributed according to the distributive law. Q and Q, then again and P. That is associative law. According to the associative law, the parenthesis will be separated for the first prepositions to second preposition Q and Q. Next, negation P, write as it is, and there is no change in the first statement, or Q and Q becomes Q. Q and Q becomes a Q, Q and P. So, this how many literals we are going to get? This is the first literal, second literal, then after that there is a 3 literals. The 3 literals are connected by using the symbol called sum. Okay, by using the symbol called sum. So, first literal is negation P. This is the product. This will be considered as a product. That is the second is a second elementary product. This is the second elementary product. Q and P is the third elementary product. The 3 elementary products are combined by using the symbol called sum. Then it is called as a sum of elementary product. This is the required format of DNF. Now look at the fourth example for the descent to normal form. There is one more special symbol called NOR. There is a symbol called NOR. So what is the formula? And we need to convert the statement into the required format of DNF. Next, negation P implies negation Q, or P NOR Q. This is the given statement. This is the given statement. First, we need to give the importance for the conditional statement. What is the conditional statement? P implies Q. P implies Q. P implies Q is nothing but a negation P or Q. That is the formula. Whereas P nor Q. Okay, that is a down arrow is there. Down arrow symbol. This is also one of the operative, that is the rarely connective, that is used in the discrete mathematics. So, P nor Q is equivalent to negation of P or Q, not or. That is a negation P or Q. Apply the corresponding formula to get the required format of descent to normal form. What is there in the place of negation P or negation Q? That is the P tends to Q is the statement. What is the formula? Negation P or Q. What is the given statement? Negation P implies negation Q. So, already negation is there. Here also negation, that becomes a P. Next, or. Negation Q is there. Write negation Q. Then, P or negation Q is the first statement, or it is the first literal, or. Okay. Then, P nor Q is written as a negation P or Q. Here, there is a 2 products are there. We need to separate the 2 values. So, in this statement, take the negation out. Take the negation out according to the De Morgan's law. If you take the negation out, then automatically we will get the negation, because we need to get the equivalent formula. We need to get the equivalent formula in DNF. So, negation P becomes a P. That's why you all take the negation. Then, or. If you take the negation out, this becomes a and. Negation will be taken out. There is no negation for the Q. That is the first literal. Or. Write the remaining statement. For this one, take the negation inside of the preposition. Here, take the negation outside of the preposition, whereas the second literal, take the negation for the inside of the preposition. Then, negation P. So, or becomes and. There is no negation for Q, then it will become a negation. Then, what is the required format? Here, it is a product. This is also product. The 2 products are combined by using the symbol called sum. This is the required format of descent to normal form. So, what we have discussed till now, what is meant by normal form, what are the different types of normal form, how to convert the given preposition into this required DNF formal form. What is the procedure we have to follow to get the required descent to normal form. Thank you.